Okay, so what I wanted to do, I'll start that again. All right, so I wanted to go over a problem that a couple of students have been looking at about finding the domain and range of a function. So the one thing to keep in mind is that the domain and the range of a function essentially is defined, we define the domain of a function as the set of all of the allowable x values of a function and the range as the set of allowable y values in a function. So when we take a look at a function like this, when we have the graph of a function, one way that we can find the domain and the range is by looking at the graph. So for the domain, graphically speaking, we want to find out how far to the left and to the right does the graph extend, what x values are represented. And for the range, we're looking for how far it extends up and down, the y values that are represented. So if we take a look at this particular example, as far as the domain goes, we see that since the function extends infinitely both upward and to the left, we see that as far as the x values goes, the graph is going to extend infinitely to the left. And to the left, we go to negative infinity. And now it keeps on going until we get to this point here, where the graph abruptly stops at 2. So for this particular part of the graph, the domain will be from negative infinity to positive 2. Now, because of the closed circle that we have there, we're going to include that as part of the endpoint. And so we indicate that with a bracket. Now, notice that the graph jumps and then picks right back up here at 3. So then we have a second interval for our domain that begins again at 3 with the open circle at 3. That means we use a parenthesis because we're not including 3 in that interval. And then it goes all the way until we have this point here, which is at x equals 6. And we have a closed circle there, so we'll indicate that to a bracket. So when we have two separate intervals in this way, we can use a union symbol to put them together. And so this expression would be the domain for that function. Now, what about the range? Well, remember that the range is the set of y values. So in this case, we look for how far the graph extends upward and downward. Now, we want to do this in numerical order. So we start from the bottom up. Now, as far as the y values go, the lowest y value that we see is, once again, at this lower point here, but now we're paying attention to what the y value is. So in this case, that's negative 4. So the range will begin at negative 4. We will have a bracket here because of the closed circle. And then it extends upward and then stops abruptly here at negative 1. So our range extends from negative 4 to negative 1. We put a parenthesis there because of the open circle. Now, when does it pick back up? Well, if we keep moving, we see that it picks back up again here at y equals 0. And then from there, it keeps going up. We have the function represented on up to infinity. So then including 0 up to infinity. So we have that second interval there, and then put our union symbol there to join those two parts together. So this gives us the domain and the range of this function. So we're just looking at where the graph is extended and what x and y values are represented in the graph of the function to determine its domain and range. So hopefully this was helpful. If you have any more questions, please feel free to let me know.